Okay, so the title is Implicit Differentiation. Implicit differentiation. Remember, differentiation really just means finding the derivative. Finding the derivative, or the slopes. Okay? What does implicit mean? That's maybe a new word for you. So you guys know what explicit means. If somebody's very explicit in their language, it usually means they're very forthright. So they say things they probably shouldn't say, right? So explicit language, you've heard that phrase. Explicit also can mean like clearly displayed. Like if I said, I have explicitly told you 50 times to do your homework, right? It's like I have very clearly stated it. There's no ambiguity here, right? Or explicit sometimes can mean very clearly and outrightly stated. So if you explicitly say something, it means you didn't imply it. You weren't just implying it, like hint, hint. You were explicitly stating it. You're very clear, right? So it means actually the same thing in math. An implicit equation is one where the independent variable, usually y, is not isolated. Okay? When the independent variable is not isolated. And then I'll write some examples for you. Here's one. X squared plus y squared is 100. That is a perfectly legit equation. It's a circle, in fact. But y is technically not really isolated, is it? So it's called implicit. Y is implied, but if you really want to get y by itself, you'd have to do some work, wouldn't you? Sometimes it's impossible to get y by itself. Look at this one. Xy plus sine y equals 100. Now you can isolate x, but you can't isolate y. It's impossible. Nobody can isolate y here. One of the reasons is simply because you've got the y on the inside of the sign and you've got the y on the outside of the sign. Good luck trying to isolate y. If you try to get the first y by itself, you'll do it by dividing by x. If you try to get the second y by itself, you'll do it by doing inverse sine. You can't have it both ways. Y is stuck. You cannot isolate it. Okay? So these are implicit equations. Implicit equations. Now, I have a graphing software I use quite often. It's free. It's called WinPlot, and you might consider downloading it this summer and playing around with it. But, you know, you can type in explicit stuff. Let me show you. You open up this software. I've shown you this before, I think. It has stopped working. Close the program. Okay, close the program. Let's try you again. I want to show you something. When you go to two-dimensional graphing, right, and you go to equations, one of the first things it offers you is explicit versus implicit. What's the difference? Well, explicit, you would actually have f of x, which means y, right? Y is isolated. Looks like default function here is x sine x. There it is, okay? But if you wanted to graph an implicit, let's say you're too lazy to isolate y, or maybe you can't isolate y. Let's do that one a minute ago where I couldn't isolate y. X times y plus sine y is equal to, what did I have? I can't remember.
X sine.
X, y, sine y equal 100. Let's just make it equal to 1.
But it doesn't say sine. It says X.
They can't spell sine with an X, can you? Maybe in some languages. Okay. And let's do a pin width 2. That's a goofy looking curve. It's not even a function, is it? Well, no wonder we couldn't isolate y. Okay. I wonder what it looks like if you zoom out. Oh, you know what I think? I think it might wiggle its way up the y-axis or something. A little sine wave up. Pretty cool looking, but you can see why your TI-89, TI-84, those calculators cannot graph those, because if you can't isolate y, you can't type them in. But they still have graphs, and they still have slopes, right? So we should still be able to find slopes, even if we can't isolate the y. Does that make sense to you guys? Okay, that's kind of our goal today, and that's the question of the day. How do you find the slope on a curve of an implicit equation? Certainly a circle, right? Certainly a circle has slopes. In fact, I think the very first time you ever drew a tangent line in your whole life, it was on a circle, remember? The teacher drew a circle, teacher said, hey, let's draw a tangent line. Isn't this the very first time you ever saw a tangent line? Yeah, so wouldn't it be a shame if we could not find the slope of this line? That'd be a shame. It seems unfair. You learned about tangent lines by studying circles, but now you're going to graph a circle and you can't find the slope? That's no good. Okay, so how do you find the equation, or how do you find the derivative if you can't get the y by itself, or it's too awkward to get y by itself? So usually what you do is you just basically take the derivative anyway. Now that you know the chain rule, you can actually use it whenever you need. Okay, so before we do this example 1, I need to ask you a couple questions. I think you're going to get them all correct. We'll see. What is the derivative of 3x to the 5th? I'll give you 10 seconds or 5 seconds to think. We're going to shout it out together. What is d dx? Ready? Go. Okay, you beat me on it. 15x to the 4th. Yes. Okay, good. Let's try another one. Erase, erase. 2 sine 3x. Okay, let's try it together. Ready? If you get it wrong, it's okay. What is it? 2. What's the derivative of sine? Cos. What's the input of the sine? You still need the 3x here. Times y times 3. Derivative of the inside. Yeah, you got it right. It's 6 cos 3x. Maybe take a minute longer than the last one, but you could get it right. Notice that 3x is still there, right? It's just the input. The input of sine, the input of sine, remember, was 3x. So the input of its derivative should be 3x. The domain doesn't change. Maybe you get a subset or something. Lose an endpoint. Okay. Any questions on that? All right. How about this one? Let's keep it simple. Ready? What's the derivative of y squared? Nope. Y, you see, is a function of x. It's an unknown inside function. Okay? The function is raised to the second power. That means the y here probably is like an x squared or a sine x. Okay? So you're going to write 2y. That's not wrong, but it's not complete. The derivative is 2y times the derivative of the inside y prime. See, y depends on x. It's a function. We don't know what it is, but it's probably sine x or cos x or 3x squared plus 5 or root x or something like that. It's an unknown inner function. So we need a chain rule. Always. The only time you don't really need the chain rule is when the inside is x. Okay? So let me ask that question again. What's the derivative of y squared? 2y times y prime, the derivative of the unknown inside function. Okay, let's keep playing that game. What is the derivative of sine y? Now the derivative of sine x is cos x, but that's not what I'm asking. The derivative of sine y, right, is cos y times, and assuming that y is some unknown expression that contains x's, I feel we need to take the derivative of it. So let me ask again, what's the derivative of sine y? Cos y times y prime, right. What's the derivative of sine x? Cosine x. We don't really need the chain rule there. But the derivative of sine y, we need the chain rule because we're ddxing a y. So at some point we're going to need a dy dx. That's this guy right here. Okay, now I like to write cos y prime. That's what I like to write. Mr. Lynch likes to write cos y dy dx. Are you guys cool with it either way? I like to write cos y prime. He likes to write cos y dy dx. It's the same exact thing. Dy dx and y prime, same thing. I just prefer the simpler looking notation. So I will just write cos y times y prime. He'll write cos y times dy dx. Okay. So what we're saying is anytime you take a derivative, as long as you keep in mind the chain rule, then you shouldn't really need to isolate y. So here's what we're going to do. We're going to take the derivative of these three things. We're just going to leave them in this form, plus 1 equals 10. What's the derivative of x squared? 2x. What's the derivative of y squared? Be careful. It's 2y y prime. The only time you don't need the chain rule is when you're dealing with x on the first term. And the right side, what's the derivative of 10? 0. So here's basically what I just did. I just ddx'd everything. If I could use ddx as a verb, I just did a little differential operator here. I took the derivative of x squared. X is the variable we use, and x is the only variable in the problem, so it's just 2x. No chain rule necessary. Here I took the derivative of y squared. Those are different variables, see that? You need a chain rule. So it's 2y y prime, technically. And the right side is just ddx of 10, which is 0. Our goal was to find dy dx. In other words, isolate this. Just treat it like a variable. We're going to isolate y prime. Here we go. We're going to subtract the 2x from each side. So I'll show my work. I'm subtracting 2x on each side. Let me get this line. And then I divide by 2y. And even simplify. They asked me to find dy dx. Now my answer is a little weird. What do you notice about my answer that makes it a little different from your worksheet last night? Well, the negative is not too unusual, but your answer has a what in it? A y in it. Yeah. We've never seen that before. Here's what's going on. We're too lazy to isolate y. Okay? So our dy dx has y's in it. But that's okay, because if I ask you to find the slope, let's carry on with this problem. We'll do like a part B. Find the slope at 6, 8. Or let's do the slope at, I need two numbers whose squares add up to 10. How about root 3 and, oh, sorry, that doesn't work. How about 3 comma 1? 3 comma 1 is on the circle. So let's say you did like a part B. Find the slope of the line tangent to the circle at 3, 1. Okay? Because after all that's going on in this is there's this circle, okay, and the radius is root 10. Yeah, the radius is root 10. So I believe 3, 1 is on here. Yeah. Okay, so the radius is root 10. We're just trying to find the slope of this line right here, this purple line. So it's kind of awkward that our derivative, this is our slope calculator, remember? Our derivative does have an x and a y in it, but listen, we can plug the x and the y into that. That's okay. So the answer is going to be negative 3 over 1. So the slope can be found by plugging in an x, of course. We've been doing that in the past. But in this case, we're just going to have an x and a y if we want to find slope. So y prime is just negative 3 over 1. And that's a reasonable answer. Look at your line. It is downsloped, right? It's sloped down. So, oh, that's the 0.13 that I drew there. Let me go back to my little image up here. This little picture, I need to swap my coordinates. And I'll just switch them in this picture. Technically, this is the 3 and this is the 1. Okay, so that's the line, the purple line, and the slope is negative 3. So the derivative has an x and a y in it, and that's okay. That's okay. All right, let's go ahead now and look at example 2. A little more complicated. See, this is a problem where you couldn't isolate y if you wanted to. Like, you don't really have that option. On the last problem, if you wanted to isolate y, you could actually do it. And then you could just use regular derivative and you'd be done. But you will get a plus or minus, and it's kind of awkward. So this problem, you cannot isolate y if you wanted to. So what we're going to do is just do implicit. Okay? Implicit means just take the derivative of everything. So let's just do d dx of x squared y and d dx of sine y and d dx of 100. The right side's easy, it's 0. It's pretty easy. And actually the second term on the left isn't too bad either. Be careful. What's the derivative with respect to x of sine y? Watch that chain rule. What's it going to be? Cos y times y prime. Yes. Cos y times y prime. Or as Mr. Lynch would write, cos y times dy dx. Okay, this first one though is kind of a pain. Notice that it's primarily a product. See that? It's x squared times y. So it's actually a product, unfortunately, which means we're going to have to do what? Product rule. Parentheses, parentheses, plus parentheses. Remove this stuff. I like smartboards because I can move my stuff. I didn't give myself enough room. There we go. Times parentheses. That's not a pen. Give me a real pen. How about that thing? There we go. Okay. So I need to dissect x squared y real quick. What's the derivative of x squared? 2x. And then we'll leave y as is. And then we keep the x squared as is, and we multiply by the derivative of y. So what's the derivative of the second factor? Y. Just y prime. So this one has two y primes in it, you see. Since we're trying to isolate y prime, I think we should keep these two terms on the left, but I think that 2xy needs to go to the other side. So let's take this 2xy over to the other side. It just doesn't really fit in. The left side is now x squared y prime plus cos y prime. Make sure your primes are obvious. Sometimes people draw their primes so small, they think it says y. These both say y prime, don't they? And this side is negative 2xy. Does anyone see a way that we can isolate y prime? That's our goal. Yeah, well, the next best thing, factor out a y prime. Yeah, so we'll divide out a y prime like this. And then divide. So all year long I've been trying to give you opportunities to factor like this, and it was because I knew that you guys would be doing a lot of it in calculus. Quite often we factor and then divide like this. So I've been trying to keep you on your toes all year that way. But this is our answer, and what's his job in life? What is this guy supposed to do for us? Find slopes, right? So we won't ask a slope question for this one, because we already did on the last one. But my next question, we will have to find a slope, okay? So it's actually not very hard. It would actually be harder to try to isolate y. It's actually just easier to do it the way we just did it. Here's our third example. I'll give you a second to copy the question. Find the equation of the lines, plural, tangent to the ellipse at x equals 1. This looks like a really hard problem. This is not a hard problem at all. You'll find out. Okay, so the first thing I'd like to do is just understand the question, because sometimes my students, they can do all these complicated calculations, but they really have no idea what they just accomplished. You know what I mean? So they never really get the conceptual side of things. They just are having these amazing calculation abilities. And I was there too at one time. So let's just make sure we totally understand the question. This is an ellipse. You could probably sketch it, right? We're not really used to seeing equals 36 here. What should we do to make this more standard form? Let's divide by 36, right? Then we can see what kind of ellipse it is and how big it is and all that. Okay, so let's divide by 36. There we go. I think we could probably even draw a pretty decent diagram here. The x-intercepts are -3 and +3. The y-intercepts are -2 and +2. And here's your ellipse. It's a little wider than it is tall, you know. And that's because your x has the larger denominator. Okay, so what was this question asking us to do? To go out here to x equals 1 and draw tangent lines? No wonder there's 2, though. Look, if you go over one space to the right, we don't know which point we're talking about. Which of these red points is it? They're both over here at x equals 1, you see. They both have different tangent lines. Okay, now the chance for you to draw a tangent line for me. I've never asked you to do it. Draw a tangent line for me. One at each point. This is on my test, by the way. To draw a tangent line, or at least on the group quiz it'll be. So, not everybody draws them right the first time. Just think this is a circle and try to make a line with tangent. Those are perfect. But every now and then I get somebody drawing totally wrong. They really are only allowed to touch the circle or the ellipse once each. Right? They do touch each other eventually. Okay, so your first one might look something like this, and then the other one like this. Does that look about right? Is that kind of what you guys had? If they do intersect, I'm sure it's somewhere over on the x-axis. That would be an awesome bonus question. Where do these two lines cross? But that's outside the scope of our discussion right now. What was my goal on this problem? Not to find where they cross, but what? Find what? What does the problem say? Find the equation, should be plural. Find the equations of the lines. Yes, right. Find the equations of the lines. We have, I cannot add an S. I copied and pasted this as an image file. Find the equations of the lines. We already have the equations of a line. We know the equation of a line. We've been doing it for years, and I've told you to use y minus y1 equals m times x minus x1 as your go-to. So there's going to be two of these, evidently. Right? Okay, both of them have x equals 1, so that's a gimme. Let's erase the x1, and let's just put in 1 here and here. These are just 1s, naturally. Okay, now think with me here. I still need two ingredients. I need y1, and I need m. Whose job is it to give me y coordinates? The original function. So if you need y1s, use your original function. Whose job is it to give me m's? The derivatives, which we haven't even done yet. Right? So I think we should go ahead right now and find our y's that correspond to x equals 1. There's two of them. Let's make x1 let's see what the y's are. That will give us the y1s here so that we can get our line a little more fleshed out. So let's make x1 try to solve that. I did it earlier and I got these two numbers. I'll show you just because I don't want to spend too much time on mechanics. I got y equals plus or minus 4 root 2 over 3. Okay, now I've got to be real careful. We're trying really hard to write the equations of our lines here. Which line is which? Let's let this top one I've written be the equation of this top one. Okay? Do you think I should use for the y coordinate for this top line? Do you think I should use the positive 4 root 2 over 3 or the negative 4 root 2 over 3? Positive, right. We're talking about this upper line. The y is clearly positive. Let's stick that in. So let's put in the 4 root 2 over 3 into the first equation. And we'll put the negative 4 root 2 over 3 into the other equation because, well, it's below the x-axis, right? So I think that makes this a plus 4 root 2 over 3, you see? So we're getting there. We still need to find m. Whose job is it again? To help us. Yes, it's the derivative. Well, nobody really feels like isolating y here and then taking the derivative, so forget that. What are we going to do? What's it called? What's the lesson of the day? Implicit differentiation. So we're going to take the derivative of this thing without isolating y. It's actually not very hard. Okay, so what's the derivative of 8x squared? Oh, what's the derivative of 4x squared? 8x. What's the derivative of 9y squared? Careful.
18y times y prime.
Yes. 18y times y prime. And what's the derivative of 36? 0. And you can isolate your y prime now. You actually get negative 4x over 9y. Notice that your derivative requires 2 inputs. That's normal for implicit differentiation. You have 2 inputs. But that's okay because we already know both the x, y coordinates of each of these points. So let's start by plugging in the 1 comma 4 root 2 over 3. That's this top point. So if I plug in 1 comma 4 root 2 over 3, I can write that like this. And it's going to be negative 4x over 9y. It's negative 4 times 1 over 9 times 4 root 2 over 3. And just clean this up very carefully. I believe it comes out to root 2 over 6. Negative root 2 over 6. I worked it out earlier. And that's the slope of my top line. So I'm going to put that in here in purple. Does it make sense to you that the top line has a negative slope? Yeah, good, good. And now let's look at the other point. That's this bottom point. The x and y coordinates are 1 and negative 4 root 2 over 3. So we'll have to evaluate the slope there too. Basically just duplicate work of what we just did. This time it's y prime at 1 negative 4 root 2 over 3. So it's negative 4x over 9y. We're plugging in 1 for x, negative 4 root 2 over 3 for y. And this time we just get a positive answer, of course. It's just root 2 over 6. No negative this time. And that's the slope of our other line. And of course it makes sense that the line below the x-axis has a positive slope. So I don't know if this is a really hard question, actually. I don't think this is a super hard question. I think what's new about it is you maybe didn't think that you could take the derivative. You would have to like isolate y first. But I'll be honest, if you isolate y first, it's a bit more work. And sometimes it's not possible to isolate y. So these two lines are the two lines we're looking for. By the way, as a bonus aside, how would you find the place where they cross? You could assume that y is 0. I'm pretty sure these both collapse onto the x-axis, right? So you could make y equal to 0. Or if two lines intersect, you can set them what? Equal. Try that. Yeah. Find the magic x where they cross out here. That'd be a cool problem. But anyway, this is my lesson, and so you guys can work on test corrections or whatever you need for the rest of this time.